Okay, hello and welcome to the week 5 CREO tutorial. This week we're going to cover something relatively basic. It's just shaft design. I'm going to show you how to make a camshaft with a spline and a keyway. Sorry, not camshaft. Conrod. No, Conrod? Crankshaft. That's the one. Anyway, yeah, so overall it's a fairly simple exercise, just a bit of extrusion. The useful learning that you get out of it is datum control, because it requires you to use multiple datums to do it easily. So we're going to start off by making one section of the rod. Let's make it 50 mil, and we're going to extrude it through a depth of 200. Okay, first part of the shaft. Now we're going to add a datum down here. So you do that simply by selecting this face and going datum plane. Yeah, translation 0. That's the first way you can add a datum. Second way you can add a datum plane, if you don't already have an object extending out that far, is you can select a datum plane you already have, go plane, and add a translation. So I'm going to want, let's say I'm going to put the actual crank part of the crankshaft over there where it connects to the conrod. And I want that to be 80 mil away. Not this direction though. So I'm going to go negative 80 mil. Okay. So now we want to add a keyway. So we're going to go plane here. Because we want somewhere to stick this keyway, let's go 120. Yeah. Plane 120, except now it's going out that way. That's more like what I wanted. So we go negative 80, yeah. So halfway through this first rod component, or about halfway, you're going to add another plane, and okay, so now taking this plane that's sitting out here in the middle of nowhere, I want you to do a sketch. I'm going to go into sketch view, and hopefully you have some familiarity already with crankshafts and the like. So pretty much we're going to take an arc and going to make the offset lobe. So I want you to draw it out like this. We're going to give it an offset of, let's go 50 millimeters. It's not a terribly big crankshaft. Although for a fishing shaft, yeah, anyway. Then we're going to make another arc, again using center and ends. You could also use 3-point and go first click, second click, third click, if you really felt like doing it that way. They're probably the two easiest ways to do it. Okay, and then we're going to, well, there's your crank lobe. Now we're going to extrude that. We want it to be 20 mil thick. And now this distance here. No, not cancel. Except, there we go. So we want to save us having to redraw the whole thing, we want to mirror this. So let's check how far this one was offset. That was offset by 80 millimeters. So we want another plane. And yes, I'm doing all of this with datum planes just to show that this is one way to do it. Halfway along, we want another plane because that allows us to go extrude. So as in selecting this extrusion, mirror about that plane, and there you go. Your matching lobes. Okay. Then we're going to do a sketch on, let's do it on this plane. We're going to add the offset shaft. So one useful thing in CREO is that if you know there's a circle somewhere but you can't quite get the important points like the center and the cardinal points to show up, the easy way to do that is to go to draw an object, select whatever it is you want to draw, say I want to draw a circle, and just hover your cursor over some line in that circle. And you'll see that then brings up these major components of the circle. So now I can make my circle coincident. And we're going to make the shaft to 50 millimeters and extrude that. Now we want it to go through the other way. We don't want it to remove material though, so we're going to select the remove material option to turn that off. See, like that, there you go. And we're going to bring this through to 100 millimeters because we've got the 20 for the shaft plus 80. And all this is showing you is that you can extrude through objects that are already there. All you need to do is make up the difference, and CREO just adds the volume to the shape. So that's starting to look a little bit like a crankshaft. Let's do another one off of this end here. So we want a circle. I'm going to sketch view. That's a radian line. And 50, it's going to be a very basic one. And then we're going to extrude that through, let's go 100 mil and accept. Okay. Now let's add a spline and a keyway. So on this datum plane that we've got here, this one that's currently halfway down the shaft, I want you to do a sketch and go into sketch mode. And see, now we really need to find this circle, so you need to use this trick of working out where the cardinal points are. And we want to make a key that's going to cut a certain distance into this circle. So given that we can, once we've got line selected, we can work out where the topmost point of this is, and we're going to draw a line that goes down by 20 mil. Oh, actually that's a bit far, let's go 15. Okay, and now we're going to make a rectangle that's going to cut through that whole length. And now if we want, we can get rid of this segment. Realistically, you probably should have used construction mode, so go on line, construction, and then drawn it, because then you don't need to worry about deleting things, but that's alright. Now we want this keyway to have a width of 5 mil. Notice that it's already centered about the central axis because of how we selected the first line. Going to hit OK, and then we're going to extrude. And no, we don't want it going that far or that way. We want a keyway 60 mil. Oh, actually that's, I think with those gears, we made them 25. So 25 mil, and we're going to remove material. And there you go, there is a basic keyway. Now, if you wanted to make a curved keyway, you could do that by taking these and revolving them. So let's give that a shot. So let's say we want an axis. So we're going to take a datum point there and there. Then we're going to use those to make an axis, because you have to have an axis to revolve things around. Now we're going to go revolve. Going to define the sketch on this plane. The sketch is just going to be a rectangle, the size of the keyway. And now the axis is going to be this one. So you see how that's currently adding material. We don't want that, so we're going to remove material. And you see there is your curved keyway, which is how the majority of them tend to be made, because cutting a rectangular one is very, very difficult, to say the least. So you usually want to do that on both ends. So let's do that on the other end, just so you get a bit of practice at it. I'm going to add 2 points on effectively the hinge axis, and then we're going to make said hinge axis. It's just convenient to use the corners of the rectangle to do so. You've got to think about the order in which you draw things though when you're going to do that. Anyway, so now that we've got an axis, we're going to go revolve. We're going to firstly define the sketch being on this plane. Then we're going to do the rectangle. Yes, you probably should go into sketch mode and everything, but it's not always the most convenient way of doing it. Anyway, so there's the rectangle. That's good, that's nice, that's defined. Now we're going to select our hinge axis and we're going to tell it to remove material, and you're done. Look at that nice little keyway, ready to fit a key into. Okay, now it's starting to look a little bit more like an actual crankshaft. Which is good, that's what we want. Okay, so finally, we're just going to add a spline. Now a spline in and of itself is a very simple thing. All you're doing is extruding and then patterning. The difficult bit comes in coming up with a repeatable way of drawing the spline. So what we're going to do is we're going to go sketch and go into sketch mode, sketch view. Our circle lies out there somewhere, and we're going to do this with construction lines, just so that we've got some references to draw off. So if this is the shaft, we want to cut away some simplistic gear teeth effectively from the shaft. They're basically just going to be triangles. Look at your textbooks if you want a comprehensive analysis on the theory of shafts. Anyway, so we're going to make these teeth 5 mil deep, and we want, let's turn construction mode off now. We want this to be center and ends, because similar to how we did the gear teeth, we want an arc length for these splines. We don't want to define them based off of some linear distance, because that's just honestly not very helpful. So, dimension, we're going to grab one end, first end, center, second end rather, middle click, and let's say we want these splines to be 10 mil wide oh sorry, 10 mil arc length rather. We're going to make it 5. I'm going to do a line then to the end of this construction line that we've made here, and back here. And now you'll notice that looks very much like half the spine, and that's because it is. So the way we're going to fix that is we're going to just accept that. Then we're going to extrude it back through 10 mil. And bear in mind, this is just one way of doing a spline. There are the ways by which you could do it are limited by your imagination, but I find this to be the most repeatable method. So now that we've got half of that, we've got an extrusion, we're going to mirror that extrusion about this plane, and there you go, it looks like we've got a full tooth. Done. Now we're going to take those and, okay, we're going to do them one at a time. We're going to pattern these around the center axis, and well, let's just play around with it, see how many we're going to need. So if we give them, I should have calculated this beforehand. Let's say if we put 20 degrees between each one, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes, sometimes the old-fashioned methods of counting are good even in complicated situations. There we go, there's the first half. Now we want to do the same for patterning the second half. I'm going to take an axis, tell it we have 18, at 20 degrees. Obviously you can do the maths in a calculator if you like. Anyway, so there's a spline. Simplistic as it may be, if you want to make it more complicated, follow the same method, or come up with your own if you feel like it, and just make the teeth whatever shape is necessary. Okay, that's about it. A little bit on cleaning up, if you so feel like it. I suppose you can try and put fillets in for design purposes. They're a good thing. Remember, we want to get rid of stress concentrations, so we're just going to go around there, around there, around there. Keyway's looking good, spline's looking good. Okay. So, the next tutorial shall be covering assemblies, and basically we're going to take this shaft, the gear we made in the week 4 tutorial, and we're going to make a frame to sit them in, and yeah, we're going to make them spin. I'm going to show you how to animate it. Bit of a mistake on my behalf. I just realized that these are 50mm shafts, and last week we did 40mm bore in the gear. That's alright. Just go back and make the bore larger. No harm in doing that. Okay, I will see you next time.